10.4 talks about the algebra of matrices. So again, remember a matrix is defined by a rectangular array of numbers. We normally use capital letters for matrices, and we give the dimensions. Remember, this is column 1, column 2, all the way to column n. This is row 1, row 2, all the way to row m. So always the number of rows first, number of columns second. To add or subtract matrices, they must have the same dimension. So they must match in number of rows and number of columns for you to be able to add them. And in that case, you simply add the corresponding or subtract the corresponding entries. So addition is straightforward, provided they match in dimension. If you take a constant and multiply a matrix by it, that would be you multiply every entry in that matrix by that number. And two matrices are equal if and only if the corresponding entries, the first entry matches the first and the second, they match accordingly. And we're going to practice some of what we just mentioned right now, and let's get started with that. So here's example 1. Find the values of the variables that make the matrices A and B equal. So if I'm glancing at those, the only way those would be equal if this is equal, this is equal. The x must equal the 5. So in this case, the x must equal the 5 and the y must equal the 3, I'm sorry. So that's the only way those two will be equal. And if I glance at this again, the 3 must equal the y and the 2 must be the x. That's the only way those two will be equal. The idea is fairly simple if you know what to look for. We're looking for each entry equal. And you notice everything else matches. Given the following matrices, perform the following operations or explain why it cannot be done. Well, I have, what is that? 3, 4, 5, 6, 8, 9 matrices. This is a 2 by 2. This is a 2 by 2. This is a 2 by 3. This is 2 by 3. This is 1 by 3. 3, oops. This is the 1 by 3. I got carried away there. And this is the 3 by 1. This is 3 by 3, 3 by 3, and 3 by 3. So first, can I find 3b? Well, to find 3b, I'm really looking at 3 and where's b? b is negative 2, 1, 0, 5. So that would be multiply each entry by 3, negative 6, 0, 3, and 15. That's doable. How about a plus 3b? Well, a is 1, 2, 3, 4. 3b I just found to be negative 6, 0, 3, 15 from example A. And all what I have to do here is 1. So 1 plus a negative 6. 2 plus 0, 3 plus 3, and 4 plus 15. And that's basically it. And if I go for b plus c, b is negative 2, 0, 1, 5. C is a 1, 3, negative 5, 0, 1, 2. This is a 2 by 2. This is a 2 by 3. Not possible. And why is that? Dimensions do not match. So the addition of matrices, the subtraction, multiplying by a constant, that turns out to be fine. The problem comes up with multiplication. It's not really a problem, but a challenge, I should say. Kind of, sort of. So let me demonstrate really quick. If I take matrix multiplication, that's a different story. To multiply matrices, they don't have to match. You line them up, the inners have to match. And if you pay attention, you notice the outcome is the outer limits. So the inners must match. Inner dimensions must match. And the outcome, or I should say, the outer dimensions would be the outcome. So, not as simple in the beginning, but let me start. AB. So A is a 2 by 2. B is a 2 by 2. A is 1, 2, 3, 4. B is negative 2, 0, 1, 5. Let me make sure I copied that right. I did. So, to get this going, this is how it works. This is a 2 by 2. This is a 2 by 2. The inners are 2 by 2. The outcome is a 2 by 2. That's going to help me figuring out what this would be. And let me show that really quick. I'm going to put it next to it. And this is how I figure this out. This is a 2 by 2. To generate this first row, this is how I always memorize it. I use the first row. To get the first, I use the first. So the way it works, you multiply accordingly. 2 times negative 2 plus 4 times 2 times 1. If I want to find this entry, it's still the first row. I'm still using the first row, but since this is the second, I use the second. And I multiply accordingly again. The 1 and the 0 plus the 2 and the 5. And that's why they have to match. Now, done with the first row. To find the second row, well, idea is repeating. To find the second row, I use the second row in the first. Again, that's how I always remembered it. You want to find the first entry, use the first column. 3 times negative 2 is a negative 6, plus 4 times 1 is a 4. And since I'm still finding this in the second row, I'm still using the second row. But to find the second entry, I use the second. 3 times 0 and 4 times 5. Not to worry, a bit confusing in the beginning. You'll get the hang of this after we do all of our examples, and I have tons of those for you to do. So, and then you of course figure those out, and you would say, well, that is 0, 10, negative 2, 20. Done. Okay, and if I want to go for BA, well, same thing. Same thing as far as multiplication, but it's definitely not the same answer, you guys. So I put B first. This was a 5, right? Yeah, I put B first, then A. 1, 2, 3, and 4. I'm going to get a 2 by 2. So again, if I remember this correctly, to find, this is always how I did it. To find the first row in my solution, I use the first row. The first matches the first. So negative 2 times 1 is negative 2, plus 0 times 3 is a 0. I'm still finding the first row, so I'm using the first row still. But to get the second entry, I use the second. Negative 2 times 2 is a negative 4, plus 0 times 4 is a 0. Finish the first row. Done. Don't need to use that anymore. So this first row, I will no longer use. To find the second row, I use the second row. And again, first entry, use the first. 1 times 1 is 1, plus 5 times 3 is 15. To find the second, I use the second. 1 times 2 is a 2, plus 5 times 4 is a 20. Let me get that out of the way. And you'll notice I will get a negative 2, negative 4, 16, and 22. And do you notice that AB and BA gave a different answer? AB and BA are not the same. Make sure you get that. Let me rearrange this a bit. And if I look for AC and see how that works, so A is 1, 2, 3, 4. C, 1, 3, negative 5. Zero, 1, 2. This is 2 by 2. This is 2 by 3. That matches. And the outcome is a 2 by 3. The outcome and here's how it works. Again, to generate the first row, I use the first row. First entry, it has to match. 1 times 1 is 1, plus 0. To generate the second, I use the second. 1 times 3 is 3, plus 2 times 1 is 2. And to find the third, I use the third. Still using the first row to generate the first row. And if I take 1 times negative 5, that's negative 5, and 2 times 2 is a 4. If you ever run out, if you ever try to multiply this and it's not matching, that means the dimensions didn't match, and you overlooked that problem. That's why the dimensions, the inners must match. And if I want to find the second row, I have to use the second row. For the first entry, I use the first column. 3 times 1 is 3, and 4 times 0 is 0. Second match, 3 times 3 is a 9, 4 times 1 is a 4, and for the last, I use the last. 3 times negative 5 is negative 15, and 4 times 2 is an 8. Now if I take all of this cluttering, oh boy, that's a lot of stuff I added. And just add those, I'm done. That is a 1, 5, negative 1, a 3, a 13, and a negative 7. If I make a mistake on the algebra, but you just need to get the idea. Okay. Now, let me look at HK. H 251 0, negative 36, and negative 1, 2, 1. K 130 042 and a 213. the area code. Okay. And if I work this out, again, the outcome is going to be 3 by 3, a 3 by 3. The outcome is a 3 by 3. So, to generate the first row, I use the first row. First enter the first, again in order. The first times the first, that's a 2, plus 0, and the last times the last, and they always match. That's why you're making sure those are the same. To get the second, I use the second. 2 times 3 is a 6, 5 times 4 is a 20, and 1 times 1 is a 1. And for the last, 2 times 0 is 0. Let me make that a bit bigger. Two times 0 is a 0, 5 times 2 is a 10, and 1 times 3 is a 3. That part is done. To generate the second row, I use the second row. Again, for the first entry, the first 0 times 1 is 0, negative 3 times 0 is 0, and 6 times 2 is a 12. For the second, I use the second. 0 times 3 is a 0, plus, minus. 3 times 4 is a 12, and 6 times 1 is a 6. And for the last, I use the last. 0 minus 6 plus 18. And to generate the third, I would use the third. Again, for the first, I use the first. 1 times negative 1. 2 times 0, and 1 times 2. For the second, negative 3 plus 8 plus 1. And a 0 plus 4 plus 3. So basically, I get out of this a 4, a 27, a 13, a 12, a negative 6, a 12, and a 1, a 9, a 6, and a 7. I'm going to stop this video here. I'll pick up this in the next video.